Hi there, I'm Dimitris Harlapidis, and in this video, which is actually part of a bigger series of videos based on the AP Precalculus syllabus, we will continue our lessons with function notation. Remember that we are still working on Unit 1 of the AP Precalculus syllabus. Now, with regards to function notation, the key concept is the following. As we have already seen a function is a special case of a relation between two sets. And by definition of the function, we said that every input value should be uniquely related to an output value. Is this relation, however, among numbers done randomly? That's the question you have in front of you. And meaning that, okay, we have a relation from 1 to 2, then from 2 to 4, then from 3 to 6. Obviously, you could imagine that what I just did was doubling the input values. From 1, I doubled it and I related to 2. From 2, I doubled that and I related it to 4, and so on. In fact, every function follows its own rule, which is called function notation. Now, usually in a function, we have two sets. We have the domain, and by domain, usually, although it's not entirely restricted to it, we have the x values, and in range, it's where we collect the y values. The function notation is the formula used to do the relations. So from x, we go to the corresponding y value through a formula f. Also, this x is called independent variable, independent value, because it's up to us to assign its values, but y is called dependent since it depends through the function's formula, the function's notation f, it depends on its input value x. To denote this dependence, we used to write that y is f of x. Now, let's work on some examples. Given the function f of x is 3x squared minus 2x plus 5, find f of 2. If you want to visualize what this thing says, imagine having two sets which are being connected through this function f. So x would be related to y, which in this case is the same as 3x squared minus 2x plus 5. So if we follow that rule, when x is 2, then the f of 2, which is the corresponding y value, should be 3 times 2 squared minus 2 times 2 plus 5. So it's going to be 12 minus 4 plus 5, which is 13. Notice that all I actually did was just substitute the input value in this function's formula. Example 14. Let the function g of x be root of 6 minus x. Now find g of 2. Regardless of how this formula looks, we keep following the same concept. All we have to do is substitute, plug in this input value instead of x. So when x is 2, the g of 2 is root 6 minus 2, which is root of 4, which is 2. Example 15. Let the function h of x equals. Hold on. What do we have here? Do we have two different formulas? Yes. This is called piecewise function. In such functions, we just need, firstly, to be able to allow ourselves to understand what it is about. H of x is 3x minus 5. Sorry, let me erase that. It didn't quite work. So it's 3x minus 5 when we are given input values less than 5, or 2x squared minus x plus 2 when we are given values, input values greater than 5. In this case, all we have to do is first understand what value we are given. H of 0. So 0 is obviously less than 5. I'm going to follow the first rule, which suggests 3x minus 5. Here we have 3 times 0 minus 5. It's going to be negative 5. For the second one, h of 10, since 10 is obviously greater than 5, I will be using the second formula. So instead of 2x squared, I'm going to put 2 times 10 squared minus 10 plus 2. It's 200 minus 8, 192. Example number 16. Given that the following mapping diagram represents function f, find f of 2. We said that what f of 2 means is the f of 2 is the corresponding output value when the input value is 2. From here, we do see that when the input value is 2, through this mapping diagram, we relate to number 7. So f of 2 would be 7. Now, let's see how we can do the same thing through a table of values. The table below presents the connected values of independent x and dependent y variables through a function g. Find g of 0, g of 4, and classify this function as one-to-one, many-to-one, or one-to-many. Here, it would be helpful if we could do a mapping diagram. At the left, I will gather all the x values, 0, 1, 2, 3, and 4. And at the right, I will gather all the output values, 5, 4, 6. I'm not going to write 4 again. I already have that. Neither 5. Now I will do the connections. From 0, we connect that to 5. From 1, we connect that to 4. From 2 to 6. Then again, from 3 to 4. And from 4 to 5. So that's the mapping diagram. We can easily see that this is a many-to-one function. Secondly, g of 0. G of 0, like we said in the previous example, is the corresponding output value, the corresponding y value, when the input value is 0. When x is 0, y is 5. So g of 0 is 5. Then g of 4. This is the corresponding output value, the corresponding y value, when the input value is 4. So again, when x is 4, g is once again equal to 5. And that would be all. If you found this video helpful, don't forget to like and subscribe on this channel. As always, thank you for watching, and I'll see you in one of the next videos. Have a great day.